Let's look at question 7 on vector quantity. A man wishes to travel due north in order to cross a river 5 km wide, flowing due east at 3 km per hour. If he can row at 10 km per hour in still water, find either by scale drawing or by calculation. 1. The direction in which he must head his boat in order to get to his destination directly opposite his starting point. 2. The horizontal velocity of the boat in the river. 3. The time taken to cross the river. And 4. How far from his destination he will land if he ignorantly steer northward. Let's bring out our given. From the question, we have two vectors in this question. One, the velocity vector, and the second one, which is displacement vector. If here is a river, and a man wishes to travel due north to cross a river 5 km wide, flowing due east at 3 km per hour. Let's say here is the starting point, and the river is flowing due east, which is 3 km per hour. The man wishes to get to his destination that is directly opposite to the starting point, from here to here. The river is flowing in this direction. For the man to get to this point, which is directly opposite to this starting point, it will steer its boat in this direction. And from the question, the man is rolling at 10 km per hour. So this will now be 10 km per hour. So from here, which is from our parallelogram law, say that the line drawn from this point of intersection represents our resultant. So, which will be in this direction. So if we are to draw them together, this will be our parallelogram. So from here, this line is equal to this line. Here will now be 3 km per hour. And we are asked to find the direction that the man must head to get to this point that is directly opposite to the starting point. So here will now be our horizontal vector. From here, we can find the direction in which he must head his boat in order to get to his destination. So this will now be sine theta equal to opposite over hypotenuse, which is equal to 3 over 10. So 3 divided by 10 will give you 0.3. So to find our theta, which is the direction, will now be equal to arc sine 0.3. This will give you 17.45 degrees. So from here, we can find our resultant using Pythagorean theorem. We say that hypotenuse square is equal to opposite square plus adjacent square. And our hypotenuse is equal to 10 square equal to opposite 3 square plus adjacent, which is the resultant square. If our resultant square will now be equal to 10 square minus 3 square. This will give you 91. So to find our resultant will now be equal to root 91, which is equal to 9.54 kilometer per hour. Here is our horizontal vector. Question 2, we are asked to find the time taken to cross the river. And from here, we say that we have two vectors, which is the other vector, displacement vector, which is 5 kilometer. To get our time from this starting point to this point, we use the displacement and the velocity, which is equal to the horizontal velocity. We know that velocity is equal to displacement over time. This will now be the horizontal velocity, which is 9.54 kilometer per hour, equal to the displacement, which is 5 kilometer over the time. To make time the subject of the formula, time will now be equal to 5 kilometer divided by 9.54 kilometer times the hour. So here will now be 5 divided by this. Our time will now be equal to 0.524 hour. And to convert this hour to minutes, we multiply by 60. Since 1 hour is equal to 60 minutes, so our time will now be equal to 0.524 times 60 minutes, which will give us 31.4 minutes. So this is the time taken to cross the river. Question 3. How far from his destination he will land if he ignorantly stares northward? If here is the river, he ignorantly stares northward from here to here, which is equal to the 30 kilometer per hour. The current of the river, which is going this way, will make the boat to shift to this direction. Here is our resultant. Here is the new direction that we both will head. This is our velocity vector. If we consider the one of the displacement vector, from the question, from here to here is 5 kilometer. Since the boat will head in this direction, our new distance from here to here, let's assume it to be s, while the current for the velocity vector is equal to 3 kilometer per hour. Here is equal to this place. Our new distance from this point to this now be in kilometer. So to find this, you look at this diagram, these are similar triangles. So from here we can get our distance, which is s in kilometer over 3 in kilometer per hour equal to 5 kilometer over 10 kilometer per hour. From here, we can cross multiply to get our s, which will now be s equal to this times this, 5 kilometer times 3 kilometer per hour over 10 kilometer per hour. So kilometer per hour will cancel kilometer per hour. So this will now be 5 kilometer times 3, which is 15 kilometer over 10. So our s will now be equal to 1.5 kilometer. So this is our answer to this question. Please click on the subscription button to get more questions on vector quantity. Thank you.